In the final section of Unit 1, we are going to study or talk about the fairness criterion that are associated with the various voting methods. Several fairness criteria have been developed to help verbalize notions of fairness so that voting methods can be compared. These criteria are not rules. If a voting method fails a fairness criterion, then that criterion just acts like a strike against that voting method. It doesn't necessarily mean that we can't use that voting method. In fact, we're going to see that all of the methods that we've talked about violate at least one of the fairness criterion. And therefore, if we were looking for a voting method that doesn't violate any of the fairness criterion, then none of the ones that we were working with thus far would be an option. An example, we would expect when using a fair voting method that if a candidate receives a majority of the first place votes, then that candidate should win. So in other words, if one candidate gets over half of the first place votes, then we would expect that candidate to win. Otherwise, many would feel like that was not a fair voting method. And you may be like, well, yeah, how could that not happen? But what we're going to see is that not all of the 4 voting methods that we've worked with thus far have that conclusion. In fact, we do have one that can violate this particular concept. And it turns out that is the first of the criterions that we're going to study, and it's called the Majority Criterion. So the Majority Criterion says this: if candidate X receives of a majority of the first place vote, so more than half, then candidate X should be declared the winner of the election. So notice there are 2 things going on there. One, we have to have a candidate that receives a majority of the first place votes. Otherwise, the majority criterion doesn't even apply. And if that is true, that we have a candidate that receives a majority of the first place votes, then we have to have that candidate winning the election. Otherwise, it's a violation of the majority criterion. So as far as which methods meet or fail the majority criterion, we're going to look at that over the next couple of slides, but it turns out that all of the 4 methods that we've used thus far satisfy the criterion except for the Borda count method. And we'll look at an example of that one in a little bit. So let's start first with talking about that fairness criterion are applied to voting methods and not specific elections. So if I tell you that a fairness criterion satisfies a voting, if a voting method satisfies a fairness criterion, then all elections using that voting method will satisfy it. So if voting method VM satisfies a given fairness criterion FC, so rather than just using generalization, let's say something like this: if plurality method satisfies the majority criterion, then every election where we are using the plurality method and the hypothesis is met, then the conclusion is that the fairness criterion is guaranteed to hold. So using those examples, if the plurality method satisfies the majority criterion, then any election where there is a majority candidate and we are using the plurality method, then the majority candidate will win. And that's what it means for a voting method to satisfy a given criteria. Now, to prove that a voting method satisfies a fairness criterion, we must provide a logical argument in which we assume the hypothesis is true. So in our previous example, that would be we are assuming that we have a majority candidate, and we have to use the rules of the voting method to show that the conclusion of the fairness criterion must be true. So in our previous example, we would assume that we have a majority candidate, and then we would use the rules of the plurality method to show that the plurality method means that if we have a majority candidate, then that candidate has to win. And I know it can be a little bit confusing, so try to simplify it as much as you can in your brain, using various examples if you have to. But the keys are that we have to assume that the hypothesis is true. Then we have to use the rules to prove that the fairness criterion will always be true. So let's look at a proof. We have the plurality method satisfies the majority criterion. So that's what we're trying to prove. Suppose we have a general election using the plurality method where candidate A receives a majority of the first place votes. So we're using plurality method, and we are assuming that we have a candidate who received over half of the first place votes. So now, because A receives more than half of the first place votes, they automatically receive more than anyone else, and that makes them a plurality candidate. So according to the plurality method, A would automatically be the winner. And so that is using the rules of the plurality method and the assumption that we do in fact have a majority candidate to show that the plurality method satisfies the majority criterion. What about plurality with elimination and the majority criterion? Well, again, we want to assume that we have an election. We're using plurality with elimination method, and we have a candidate that receives a majority or over half of the first place votes. Well, think about what is true about the plurality with elimination method. Plurality with elimination says if in round one you have a majority candidate, then that candidate wins and the election is over. So by definition, we can stop after round one because the majority candidate will be declared the winner at that point. So the majority criterion has been satisfied, and that means that the plurality with elimination method does satisfy the majority criterion. Pairwise comparison and majority criterion, same thing. We're going to try to prove that pairwise comparison meets the majority criterion. So we're going to assume we have an election that has a majority candidate, and we are using the method of pairwise comparison. Well, remember that to win the method of pairwise comparison, a candidate must have the most points, and that means they must win more comparisons than any other candidate. Well, if you have a majority criterion, how many comparisons are they going to win? All of the comparisons that they are in. They have more than half of the first place vote, and therefore they are going to beat all other candidates. So, since we know that A has more than half of the first place votes, we know that they will receive more votes than any other candidate in any comparison. That means they will win all of their comparisons, and therefore they will be declared the winner of the pairwise comparison. So we've talked about how to determine if a voting method satisfies a fairness criterion, but what about if we're trying to show that a voting method fails a fairness criterion? Well, in that case, it's a little bit easier actually, because all we need to show that it fails is at least one example of an election using that method that violates the criterion. So you don't have to prove that it's always going to happen, because it won't always necessarily happen, but all you have to do is show that there is one time that it happens, and that's enough to say that it does fail or violate the fairness criterion. So let's talk about Borda count and the majority criterion. And what we're trying to prove here is that the Borda count method does not satisfy the majority criterion. So let's look at this example. What I want you to notice is that we do have candidate B here with 26 votes. There are a total of 50 voters, so 26 is the minimum required for a majority. So B is in fact a majority candidate. However, if we use the Borda count method, we will see that C actually wins the Borda count method. How does this possibly happen? Well, notice that B is just barely a majority candidate, and that everybody who didn't rank them first ranked them dead last. C, on the other hand, came in here and received almost all second place votes. So because B was pretty much either loved or hated, and C was pretty much middle of the road for everybody, C was able to receive enough points to be the winner of the Borda count method, even though they were not a majority candidate. And so that's enough to, this one example is enough to show us that the Borda count violates the majority criterion. Now, notice that the fact that C won and wasn't a majority candidate is not enough to show that. It had to be that we had a majority candidate and that majority candidate didn't win. That's what showed the violation. Another way of saying that is one bad apple is enough to show that the method violates a fairness criteria. However, note that it is still possible that you will have elections where there is a majority candidate and they will win using the Borda count method. It doesn't mean it's always going to fail. It just means that it could. All right, so a recap. To show a voting method satisfies a fairness criteria, we have to assume the hypothesis of the voting method and the fairness criterion. And then we have to provide logical arguments using only the hypothesis and the rules for the given voting method. And then show in conclusion that the voting method meets the conclusion of the fairness criteria. And one thing that throws students a lot is this assumption of the hypothesis. Remember that if a hypothesis doesn't exist, then the fairness criterion can't apply regardless of anything else. For example, the majority criterion cannot apply if you don't have a majority candidate. Everything else goes out the window. If there's not a majority candidate, then the election neither satisfies nor fails the majority criterion because the hypothesis hasn't even been met. And to show that a voting method fails the fairness criteria, you simply need to find a single election that violates the fairness criteria. However, make sure that that example that you provide does meet the hypothesis and does not meet the conclusion. So in other words, if you were trying to show that it failed the majority criterion, you would have to show an election that had a majority candidate, but that did not let that candidate win. If you have an election that doesn't have a majority candidate, then none of this applies, and so you can't use that type of an election to show that it fails.